Greetings CoCoRaHS observers and welcome to this CoCoRaHS winter weather training. My name is Alyssa and I'll be the one walking you through all things winter weather today. As I said, my name is Alyssa. Here is my email address for you if you have any questions after this training session. I am a meteorologist at the Albuquerque National Weather Service office. I'm also the CoCoRaHS program leader here at the office, and I'm also the regional coordinator for CoCoRaHS in the state of New Mexico. Essentially what all this means is I am here to support you in all things CoCoRaHS. So please, if you ever have any questions about CoCoRaHS or about anything that you're going to see in this training session today, please don't hesitate to reach out to me. But of course, we're not here to talk about me today. We are here because we are knocking on the door of our winter weather season, and before you know it, we are going to have to start measuring and reporting snow. So let's dive in. Let's talk about what that means. Now, as I'm sure you're aware, measuring snow is much more difficult than measuring rain in your gauge, and to be honest with you, it's typically not a favorite of most observers. But it's still a vital observation, which is why it's important that we get it right. There are some extra things that you are going to need when measuring snow. First, you'll need to make sure to remove the inner cylinder and funnel from your gauge because you need just your outer cylinder. You're also going to need a snowboard, which is about a 16 by 16 inch piece of wood at about a ½ inch thick. Of course, you're going to need a ruler or a yardstick to measure the snow in tenths. And you're going to need your handy dandy snow swatter, which is really just something like a fly swatter in case snow collects along the rim of your gauge. Before it starts to snow, you're going to need to get ready. So when you're expecting snow, be sure to place your snowboard outside. Be sure to avoid any areas in your yard that are prone to drifting. We don't want to measure in any snow drifts. If you're expecting a lot of snow and there's concern you might not remember where exactly you put your snowboard, then consider a flag or some other marker so that you know where your snowboard is. And finally, be sure to remove the inner tube and funnel from your gauge so that all you're left is your outer cylinder, like the image you see here on the right. The outer cylinder's job is to collect the snow, and it will have a much easier time doing that with these pieces out of the way. Now, there are 3 primary measurements when it comes to snowfall. The first one that we're going to be talking about is the depth of the new snow. Simply put, this is just the amount of snow that collects on your snowboard. If you don't have a snowboard, then find a level place in your yard to measure. But remember, avoid measuring in any drifts. Now, for most of you, your observation time is typically 7 or 8 o'clock in the morning. You're used to checking your gauge at that time every day. For snow, though, it's a little bit different. When it comes to measuring the depth of the new snow, it's important for you to do this measurement as soon as possible after the snow ends. So, for example, let's say that it starts snowing at about noon and it continues through about 6 o'clock in the evening. You're not expecting any more snow after 6, so now's the time for you to go outside and take a measurement of the snow on your snowboard. If you wait until morning, then the snow is likely going to start to melt and settle, and then you're not going to get an accurate measurement if you wait until 7 o'clock the next morning. Make a note of what you measure so that it can go on your next precipitation report in the morning. Be sure to measure to the nearest tenth, so 2.5 inches of snow, 3.2, etc. Once you've measured, make sure you wipe your snowboard clean and set it on top of your freshly fallen snow so that it's ready to go for the next snow event. Of course, a lot of the time wind is a factor during winter storms, and the wind can make things a lot more challenging. If you experience strong winds, then odds are that snow drifting has occurred. In this case, you may need to take several measurements around your yard and average them together to get a snow accumulation report. So here's a look at our typical daily precipitation report, and the red box highlights where this measurement goes. So in this example, we measured 1.3 inches of new snow on our snowboard, And we have put that in the box that's labeled Accumulation of New Snow in inches to the nearest tenth. Now, if you're only going to remember one thing from this presentation, I want it to be this. It's a common mistake for observers to put the depth of the new snow in the precipitation box, the one that you're most used to, the one that you report your rainfall. But please don't do that. This is not the box for your snow reports. If you put your snow in this box, then it's going to trigger a quality control ticket, which we are going to talk about more in depth later. The second snow measurement that now we're going to talk about is our liquid water equivalent. So this is the part where your outer cylinder is going to come into play. But let's say that you go outside in the morning to fetch your cylinder and it looks like this. Well, what do you do with the snow that is collected along the outer rim? Well, this is where your handy dandy snow swatter helps. Take the snow swatter and tap it gently on the rim of your gauge. What falls in, you measure. What doesn't is left out. Now we need to take whatever is in our outer cylinder and melt it down for our liquid water equivalent measurement. Now, of course, we can take our gauge inside and be patient and let the snow melt naturally. But of course, we're all busy people with things to do and people to see, so if you don't have time to wait, then of course we can hurry this process along. You can take a pre-measured amount of hot water and add it to the snow. It's very important though that you measure the hot water first before adding it to the snow. Once your snow melts, then we're going to add that to our inner tube and measure it. Of course, if we added hot water, then it's important for us to subtract that total. And this is our liquid water equivalent of our snow. Now, pictures are worth 1,000 words, so let's see what this process actually looks like. So here's our outer cylinder full of snow that we need to measure. You can see there's a lot of snow in here. We also have our inner cylinder handy for when we need to measure the liquid. Now, like I said, that's a lot of snow, and waiting for it to melt would take a long time. So in this case, we're going to add a pre-measured amount of hot water. So here we are, we've put in some hot water in our inner cylinder. You can see he's taking a look to see how much hot water he's adding. We're going to pour that hot water into our outer cylinder to quickly measure our to quickly melt our snow. And we're going to pour all of that back into our inner cylinder to take a final measurement. Of course, but don't forget to subtract. Let's say that after all that, we measured 0.27 inches of liquid in our inner funnel. However, before we added 1.13 inches of hot water. So we need to subtract that out, and eventually we get 0.14 inches. This is our liquid equivalent of our snow. So let's go back to our precipitation report. We need to add that in. So the box that's highlighted in red, this is where our liquid equivalent goes. This is the one that's labeled rain and melted snow to the nearest hundredth. Unfortunately, our gauge isn't always going to give an accurate measurement for snow water equivalents. Of course, wind may deflect snow everywhere except in your gauge. In these instances, a core sample may be necessary. So in order to take a core sample, we're going to take our outer cylinder, we're going to stick it upside down into an area of snow that is representative of how much snow you received. Take your snow swatter or some other object and slide it underneath your outer cylinder so that you can lift the snow upward before flipping your gauge over to collect the snow. If the snow is deep enough, you may get lucky and just be able to stick your cylinder into the snow and pull it right up with your snow inside. Then we're going to follow the same instructions we just went over to melt the snow and measure your liquid equivalents. Alright, the third and final measurement we're now going to talk about is the depth of the new and old snow on the ground. This measurement is simply the amount of snow on the ground at your observation time. Of course, snow rarely falls uniformly, so be sure to measure in a few different spots in your yard and average them together. And of course, be sure not to measure in any drifts or any other artificial snow depths, such as snow piles or shoveled snow. Now let's go back to our daily precipitation form. This measurement is going to go in the box labeled depth of total snow and ice. So in this example, remember we measured 1.3 inches of new snow on our snowboard, but around our yard we measured a snow depth on the ground of about 2 inches. Sometimes precipitation is much more complicated than just rain or snow. Occasionally you may have freezing rain to deal with. So how do we measure and report that? Well, first, what is freezing rain? Freezing rain is water that falls to the surface in its liquid form. So as it starts out as rain, but because of the freezing temperatures at the surface, that rain freezes on contact once it hits the ground. It's important to remember that freezing rain is not snow, so please don't report it as snow. If you experience freezing rain, then you'll follow the same procedures though as snow. Namely, you'll need to take what fell in your gauge, melt it down, and report that as your daily precipitation amount. Make sure you put a 0 though for your new snow amount. And then if you can measure the depth of the freezing rain on the ground, please feel free to do so. Just be sure to enter that in your total snow on the ground box. But be sure to leave a comment so we know that what you're reporting is freezing rain. So that's the basics of measuring and reporting snow. Before we go on though, I do want to briefly discuss a couple more things, starting with significant weather reports. Significant weather reports are a great way to alert us at the National Weather Service if you're experiencing very heavy rain or snow. Once you submit a significant weather report, we get those immediately, and they can make all the difference in whether or not we issue a product. Perhaps a winter storm warning, or in the winter, or a flash flood warning in the spring or summer. So this is what a significant weather report looks like. Of course, be sure to put the time of your report in. How long does your report cover? 20 minutes? 30 minutes? Be sure to enter that. Here's where you enter your heavy rain or heavy snow information. So in this example here we have how much rain has fallen during this report duration. And here's where we have how much snow has fallen during this report duration. If you're experiencing any flooding, you can also let us know here. And finally, notes are always helpful. If there's something you feel is important to let us know that's not covered in this report, please let us know in this note box. Finally, the last thing I want to touch on today is the quality control process. I really can't stress this enough. Your observations are so important. They are used by so many people. And because of this, it's very important that we maintain an accurate database. So the QC process is a very important part of CoCoRaHS. The first thing I want to stress is that if your report is flagged for a possible error, please don't fret it. Mistakes happen. Nobody is judging you. Nobody is mad at you. We just want to maintain the most accurate database that we possibly can. So occasionally we may reach out to you to verify if something is correct. So what does this process look like? Well, there are people who scan these reports on a daily basis looking for potential errors. If a report is suspected of having an error, then it is flagged. And the suspected error is usually removed from the report and replaced with an NA until it can either be verified or corrected. So here's an example. In this case, the observer put 9 inches in their daily precipitation field. Now, I hope after this training you can spot the error. Given the time of year, this is likely a snow error. The observer got 9 inches of snow, but they put it in the wrong box. Now you can see that the 9 inches of snow was removed from the report and replaced with an NA. There's also a note in the comments section explaining that there's a possible error. Now, by the way, this is not a real report. This station is actually our CoCoRaHS station at the Albuquerque National Weather Service office. I'm not picking on anybody here. If I am, then I'm just picking on myself. Now that an error has been identified, I get an email. Every time a QC ticket is opened, I get an email about it. And then it becomes my job to reach out to the observer, you, to try and verify or fix what is wrong. So now it's your turn to get an email, and here's a snapshot of what the beginnings of that email might look like. Remember, don't fret it. If you get an email from me about a possible error, go take a second look at your report. If there's a mistake, we can easily fix it. So here we can see that we have now fixed that report. The 9 inches of snow was moved to the appropriate box, and all is well. The one thing I do ask is that you please don't ignore me. If I reach out to you about a potential problem, then please take a minute and respond to me. If you don't, then your data is going to remain missing, and nobody wants that. And that's all I have for you. Thank you so much for watching. Please feel free to reach out to me if you have any questions. I also highly recommend the CoCoRaHS headquarters YouTube channel for any quick trading videos that might be useful as well. Thanks again.